Hello, we are Chung and Kamo. Today we are presenting our final project with the topic finding redundant files in Alloy for the course formal methods for software engineering in Bauhaus University, Weimar. Our presentation today contains three main parts. First, we will go through an example about the redundant files in Alloy. After that, we will show how we implemented our tool to find and remove the redundant files in an alloy model. And in the last section, uh, we have some discussion and conclusion about what we have done in this project. For the example of redundant files in the alloy model, we can see here the model on the left side. The file number 2 is contain no new information and it does not affect the result of the model. So when it is here, it causes confusion and it also consumes the space of the model. And when we read all the facts, we need to remember uh, unuseful information. And after we run our tool, we already remove the redundant fact. The fact number 2, and we can see it's shorter, clearer, and is less confused and maybe more optimal for the alloy tool. For implementation part, we implement our tools by on uh, this formula. So we state that the fact is redundant if uh, all other facts without that fact is implied in that fact, and it can be also stated that like uh, the model will not be satisfied if negate of, of the state that we say above. Here is our call function to handle that based on the formula we saw above. For the detail, we will have a demo session and we will talk in more detail about the implementation in the demo session after this presentation. And finally, we think our approach is a reliable solution for removing redundant files in alloy models. However, it still has some limitation. Um, for example, it is now limited to identify redundancy only on the first level files. It cannot break up the complex expression and finding the redundant in redundant component in complex expression. And finally, we think our solution really has the potential for future development in this field, so that the user can use this tool to find redundant facts in a very complex alloy model and remove them from the model. And now we will have a demo on how our tool running.
Hi, this is Kamal. I continue our presentation. I want to first present our main class. It's Alloy Analyzer class. It's our main class that we have implemented for our tool. First, we create a model word naming in here that has the input of our file name. After creating our module, we should search for the redundant facts in it. First, we get all the facts by its command. and then we make a list of all facts in this comment, because the comment consists all the facts in it. And then we should go through one by one in the fact list. We call the fact list final list actually in here. Then we choose one fact. For example, we say that the name is temp remove fact, and we should analyze that fact. First, we remove that fact from list of all facts. Then we make a new formula that is made of and between all other facts. By that new formula, we make a new comment. Uh, by this comment, that is consists of all other facts, we should see if it implies the fact that we are examining, and if it the negate of that fact make a module that is not satisfiable, uh, we can say that fact is redundant. So when we see this is not satisfiable, we can add that the fact that we were examining to the list of fact list. We call that in here redundant facts expression list, because it saved the facts expression. But if we want to get the fact as it in the format of alloy string format, we should use another helper method. It we named that get string fact string, sorry. We input the expression in this method, and based on this position in the input file, it returns the string of the expression. So now we have the string of the fact, and we can add that to another list, naming redundant facts string list in here. We have other methods in here. For example, in here we have write new alloy. If we want to make another alloy file that has removed facts, removed redundant facts in it, we invoke this method. And here you see the list of helper methods that we use, but they're private because we just use them in the alloy analyzer class. Now I show you a demo. For example, here we have product price example. In the product price, we see that we have a signature product that has a field of price and discount. If the price, the first fact says that if the discount is greater than 0, and the discount should be less than price. The second fact states that the price minus discount should be greater than 0. So we can already see that these can be derived from this fact 1. And the third fact says if two products have the same price, they should have the same discount. So now I run the demo. As you see here, it says that fact 2 is redundant because we printed out the list of redundant facts in the string format in here. And we also printed out the list of redundant facts in expression format, and so you see this fact in the expression format in here. And then we try to make a new model by invoking this method, write new alloy. And as you see, now I have let me refresh. Now I have an output alloy model in here. Then I see that there is no fact 2 in it. Also, there are several examples for our tool that we examined. For example, in the house example, all facts are written in one instance. For example, in here, if I change the input source to houses, I run the program again. You see that there are 2 redundant facts in it, and in this is the expression format of this redundant. And if I want to show it is the original alloy format, as you see here, we have a major in house major, and we have h3.major equals field. But if I show you the output alloy, there isn't these 2 facts in the list of facts again. Thank you for consideration.